Hello, everyone. Thanks for joining us for our next live session. I'll be your producer for our session, but before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer. Our session is being recorded. It will be available to view on demand right here on the Microsoft Reactor channel. With that, I'll turn it over to our speaker for today. Thanks for joining us.
Okay, welcome to New Breakpoint, Microsoft's digital event series designed for developers by developers. I am your host, Michelle Sandford, the Developer Engagement Lead for Australia, New Zealand and Asia. We broadcast on the second Thursday of every month, and if you'll join us on the day, my guests and I will answer your questions live in chat. As you might know, New Breakpoint has expanded to encompass Asia Pacific, meaning we now bring interviews with developer experts from all over Asia. Today, we are welcoming Barath, Nalipeta and Randy Bias from Mirantis. Welcome, boys. Why don't you tell me a little bit about yourselves? Barath, you want to go first?
Sure. Hey, Michelle. Hi. Thanks for tuning in, whoever's watching, and welcome to the new episode. So I'm Barath from Mirantis. I work for the OSPO team, and yeah, we've been completely, in the weeds in everything Kubernetes and AI. That's pretty much about it.
Awesome. So you're a consultant, an architect?
No, I lead the team at OSPO, Open Source Program Office at Mirantis. So primarily we do development work.
Perfect. Randy?
Hi, I'm Randy Bias. I run the Open Source Program Office. I also am sort of a jack of all trades. I get pulled into a lot of things. I am responsible for a bunch of our new AI and ML initiatives, particularly around Kubernetes, AI ops, ML ops, that kind of good stuff. So.
Cool. So today we are going to talk about platform engineering. It is a huge topic, but maybe not everyone in the audience knows what we mean by that. So, Randy, do you want to maybe just tell us a little bit about what you would say platform engineering is?
Yeah, so I'm going to give you my perspective, which would probably be a little bit different than sort of a traditional canned response. And I'm just gonna give it from my perspective because I think it's a little bit more kind of from the heart, so to speak. So when I started off my career, it was really interesting. I started off in systems engineering, and my very first job, I noticed everybody was doing everything manually, and it drove me crazy. Like I couldn't understand why anybody would do anything manually. Why would you do something, manual when you can have the computer do all the work for you, right? So I automated my way out of as much work as I could do. And I just kept doing that from job to job, even as I transitioned into network engineering and cybersecurity. I was all about building automation tools. And so, kind of towards the midpoint of my career, I got involved with this tool called Puppet, which at the time probably had 30 users. This is in mid to late 2006. Nobody had heard of it. And I was using it to deploy in-tier web applications onto this other system called Amazon Web Services Elastic Compute Cloud, which was in private beta. It had only one feature, which is you could get one instance type, one, for 10 cents an hour. That was it. No EBS, no load balancing, none of those things. But, it was one of those kind of aha moments. I was like, wow, if you're a developer or an operator, you've got this API in the sky that you can call, you can dial up whatever you want, and you can build the automation so you don't need to worry about the infrastructure, the networking, all the pieces. And that was sort of like, I realized that the game was really going to change. We're going to move into this era where automation was the de facto default. And so that was the beginning. DevOps kind of evolved from that point in 2008, 2009. And I think platform engineering is just the natural evolution of that, right? Which is, how do enterprises get to a point where they have some kind of system that's akin to what the hyperscalers have, so that their developers have the least pain possible doing development in local environments and then moving that to production environments? And the answer is that there has to be some place where you negotiate. And I think part of what Kubernetes kind of gave us is it gave us that negotiation point between the operators who are running in production and the developers who are writing the code. Maybe neither group is 100% happy with Kubernetes, but they both know how it works. It's kind of a meet in the middle spot where, the developers know how to get their code and run it on it. The operators know how to troubleshoot the code in production. And that feels like it's evolved into platform engineering, which is, okay, now that we have Kubernetes, which has lots of sharp edges, how do we build a system on top of it that makes deploying applications via Kubernetes easy, painless, through well-trod paths? And so that's kind of what I think of platform engineering. So it's kind of a long-winded answer, but I think it's the final frontier, so to speak, in terms of sort of that negotiation point between enterprise developers and enterprise operators who are running those applications in production.
Yeah, you mentioned Kubernetes. What role would you say that Kubernetes plays in your platform engineering strategy?
It's one of those things where I'm not sure that everybody loves Kubernetes. I'm sure that many people do, but it's not the best technology that always wins. Sometimes it's the most flexible, it's the most broadly adopted. And I think back in the past where you saw something similar to this, and I would say it was sort of like the JVM era when Java was big and you had WebLogic and WebSphere. You had these relatively standardized platforms for getting Java applications only up and running in production. And again, you kind of had this handoff point where the developers knew how to get their Java applications to run on the JVM, and the operators knew how to run the JVM in production. And you kind of had like enough of sort of like that same meet in the middle point that everybody was happy or happy-ish. But of course, that was only for Java applications. So I think what Kubernetes has done is it's become the de facto delivery mechanism for applications. Like that is the go-to now. Like that is the default. Everybody runs their applications on Kubernetes. I was talking to one of the Nordic banks a couple months ago, and they have 400 Kubernetes clusters. And I said, well, how many of those Kubernetes clusters are actually running cloud native applications? And they said about 25%. So 100 clusters running cloud native applications, 300 clusters running non-cloud native applications on Kubernetes. And I think that's just kind of the world we've entered into, which is that Kubernetes is less about cloud native applications, is more about any kind of application and the ability to package it up so that you've got a single place that you know where to go to deploy, to manage, to do kind of the full life cycle of those applications. And it allows the operators to use the same tooling that the developers use, so that the way it is on a laptop or in QA or staging is the way that it is in production, or at least mostly. And I think that's kind of been sort of what has made Kubernetes successful, more than its architecture, more than a lot of different things. It's sort of the good enough solution for every single application to be run and deployed and managed.
If I may jump in just to add a point. So Randy always says that it's not always the best technology that wins. And like there's been so many examples if you look at technology history for the past 30 years to prove that point. Another reason that I feel Kubernetes is winning is because of the ecosystem it has built around it, right? So even individual developers are literally maintaining a full-fledged projects which are running in production systems all around the world. And then there's full-fledged companies like the big guys like Microsoft and Google and Red Hat, and all these guys are also sponsoring certain projects, working together with the community to drive, a few important technological pieces around the Kubernetes ecosystem that again run in production systems around the world. So I think this is one of the major reasons that anybody can just quickly start and then contribute in whatever way they can towards the ecosystem. And one of the best examples to further prove this point is the observability stack, right? Nowadays, whenever we go to any conferences, like there are more booths and sponsors for observability companies than any other, sector out there. That's because it's a genuine problem. It's because it's a problem that's worth solving, and everybody's got that little addition to someone else. They have this X factor that they want to contribute and show to the industry, right? So I think that's one of the major reasons.
I should ask about Mirantis a little bit. You're an open source company, is it?
Yes, that's 100%. In fact, I'd even almost describe us as maybe not the Kubernetes company, but one of the Kubernetes companies. Mirantis really started to grow as a business in 2011, 2012, when we embraced OpenStack in the early days before Kubernetes. And then we continued on a pretty steep trajectory as Kubernetes came along, and we jumped on the Kubernetes train. But we've always kind of been a Kubernetes first business. We started off doing, open source for hire, basically. We were very mercenary. And then we eventually did a pivot into more kind of product-based, open source-based products with our OpenStack product. But we took our OpenStack product, and in order to run it in production, we put it on top of Kubernetes, both the control plane and data plane. So it's literally called Mirantis OpenStack on Kubernetes, MOSK. And then, we went on to do a lot of work in the Kubernetes community. At one point, we were a top 5 contributor. We had our own Kubernetes enterprise distribution. We now have K0s, which is our own Kubernetes downstream, hardened distribution. And generally, pretty much all the work that we're doing these days is all around Kubernetes. Like I said, from our perspective, Kubernetes won the application delivery platform war, if such a thing ever existed. It's really the de facto go-to. And when we're looking at things like platform engineering, it doesn't make sense to build on anything else. Yes, you want to abstract out Kubernetes so that your developers aren't in YAML hell, because the idea behind platform engineering is to reduce toil, right? But, it's an ideal platform in that regard because, it's very much designed for templatizing. It's designed for reusability and composability. So if you kind of like add just another layer or two of abstraction on top of it, you can kind of clean things up, make it easier for developers to use it. And in the case of large enterprises where you're trying to get your developers to go down, these well-trod paths, golden paths or whatever you want to call them, you can pre-vet those in advance and then make sure the developers have a very easy way to go into a portal or an API interface and say, give me a template that's like this for, Java applications, for Drupal, for whatever the thing is that I'm trying to get deployed and in production.
I guess one of the questions that comes to mind then is how do you balance community-driven innovation with enterprise-grade reliability?
You're starting with the tricky questions. It's a challenge. It's a challenge. I think it's a challenge for everybody. In particular, I was brought on board in Mirantis to kind of solve this because we maybe over-indexed onto the enterprise grade supportability, right? Like we're running Probably 25% of the world's credit card transactions run over our Kubernetes clusters on a daily basis. I can't name that customer, but you could probably guess. So we have some very large Kubernetes deployments that run, 4 to 5 nines of uptime. And in some ways, we kind of got too far down, kind of, focusing on the enterprise grade, and then had to kind of dial back into community. That's why I was brought on board to start the open source program office. But it's a challenge. It's an ongoing challenge, right? And fortunately, I saw this, in previous roles at Juniper and EMC, where we just didn't have the executive will to do it the right way. Whereas at Mirantis, we have, I've got support from the CTO and CEO, and they believe that strategically open source has to be a number one priority for us. And that downstream from that comes our success on the enterprise side, which is a little bit different than what I saw in my previous gigs. So it's really required that kind of like will and ability and commitment to invest into the open source side. But it's a constant balancing act where we're trying to figure out like how much we invest on each of those, with the understanding that if we can be as smart as possible about how we engage with communities on the open source side, that leads to better enterprise products. It's just it's quite a bit harder to draw a straight line connection, right? When you're talking about the enterprise side and you've got a customer request coming in for a specific feature and you implement that feature, you can kind of, connect the dots and say, when we add this feature, we get this customer, which leads to this kind of revenue. When it's on the open source side and you're fixing bugs, doing enhancements, updating documentation, creating tests, it's a little bit harder to draw the connections to sort of the return on investment. But fortunately, we have a business at the executive level that wants to establish a culture where we strongly believe in open source.
Yeah, I remember when Satya came in as our CEO, and he, really went all in on open source at that point, and our company became the largest contributors to the open source community in the world, which people couldn't really understand how that all meshes together. An enterprise grade company supporting open source to such an extent that its employees were contributing that much. But when you think about it, it kind of makes sense. If you're going to hire the best talent in the world, why wouldn't you be hiring the guy that invented Linux or the guy that invented TypeScript or whatever? And these are all open source community people that made their passion projects into something so huge that it then, it then became unstoppable, and hiring those people only makes sense. Do you have that in your hiring practices, that you're hiring people who have been making contributions and that's how you notice them, or is it further along the process than that?
That's absolutely part of the process. We have Nathaniel Copa, who's the primary maintainer for Alpine Linux on the team. We've got a number of other people who are like that, who have passion projects outside. I personally have a couple of my own. I'm just a small scale developer. I don't make any pretenses to be anything more than that. But we absolutely encourage that inside the business and the team, and that's part of how I find people, although not the only way. I'm always looking for the right kind of fit on the team. So folks like Barath, he's been one of my superstars. That's why he's here doing the demo today. But he's got that background coming out of Red Hat and SUSE, and just being very committed to open source. So it's interesting though, right? Because we definitely have some elements of the business, some engineers where they can give it or leave it, take it or leave it, excuse me, where they're open to doing open source, but no, they're not necessarily passionate about it. But the open source program office, which I run, is really more about the teams that are more passionate about open source and believe in it and are deeply committed to it. And that's kind of the culture we're trying to establish across the business as we grow and expand.
So you definitely advise all the students and junior devs out there to start contributing to open source, because it's not just something that you do for fun, it's something that can lead to a career working in great companies like yours.
I mean, it's great marketing for individual developers. I don't know why you wouldn't do it, but I do think that like it's best when it lines up with sort of a passion for it. The way that I think about it as an individual developer is that the worst thing that can happen as an engineer is to write some code that nobody uses. Like that's like the product of your labor nobody cares about. It's like an artist who nobody will buy their paintings or their artwork, right? That's like literally the worst thing that can happen. So, the great thing about open source is that your contributions, the code you work on, the things that you do, they live on beyond you. There's a community that's going to engage and use all the product of your work, and you could feel really good about it. So and then of course, as you're saying, it's just built in natural marketing and just kind of on a side note, like I've even seen a number of my team who have traditionally been just the nose to the grindstone open source contributors go that next level when I ask them to, which is to go out and do presentations at meetups and small scale events talking about their work when they hadn't done those kinds of presentations in the past. And I was very proud of them. Tom on the K0s team, Juan, Serhi, a number of people, kind of just really stepped up. And I think that's all part of it, right? Love what you do, push the code back, go out and tell people about how awesome it is. And, how can you lose in that kind of situation?
Yeah. And of course, I saw Barath at DevOps Days Singapore. And he's all over the place as well. Can't stop him talking about.
It's interesting, really. I've been like attending a few conferences, and the student community and then junior engineers have just been like 1 to 2 years in their career, right? Like they just don't know the entire ecosystem already. So these guys are getting a lot of good exposure to open source as compared to, like, let's say 5 or 10 years ago, right? And they don't really shy away from contributions, no matter how small or big they are. And that's the thing. People used to have this notion earlier that if I have to contribute, I have to dedicate like a whole bunch of time and then effort and all that. But no, like it could be a really simple docs update, right? Like improve docs, and that's really impactful. Sometimes even more so than code, right? So there are these small ways also where you can contribute towards open source. And personally, I think I'm seeing that growth, especially in India and other countries in Asia that I've been to, which is really good for the community.
I'll take it. I'll take that one a little bit further, Barath. I'd say docs have become even more important in sort of like AI world, because a lot of time, if you want to feed the LLM like the right context so it can figure stuff out, you've got to have docs that are accurate. So I'm finding that docs more and more are becoming vital to sort of like, what the future looks like in IT.
I think they were always really, really key, but nobody wanted to do them. And so you could easily become a very valuable member of the team if you were willing to write good documentation and able to write good documentation. I think AI definitely has sped up the process of writing docs, but you've got to keep that human in the loop if you want to be sure that those docs are going to be 100%. What you intended them to be, for sure. Yeah. AI definitely gets carried away with stuff, and it can go down some rabbit holes if you are not watching what it's doing. Cool. So what are we going to look at today, Barath? Are you going to show us something cool?
Okay, so we've talked a bit about platform engineering and Kubernetes and how they really are a nice fit, how Kubernetes abstracts away a lot of things that one would manually have to do, have literal teams built around it, and have the sort of maintenance burden, right? Again, it's not like I'm trying to sell Kubernetes as a superhero who does everything and anything, but certainly the abstraction has gotten much better, and the size of the team and the effort it takes to do the same exact thing has gotten better, right? So that being the core philosophy or principle with Kubernetes for platform engineering, Mirantis has an open source product called as Cordant, right? So what, in very simple words, what Cordant is a multi-cluster, multi-cloud orchestrator. So like Kubernetes orchestrates for one particular cloud or one cluster, you need sort of a super control plane to manage multiple clusters across multiple clouds. So the reason I'm stressing those multiple clouds is because we've done a lot of research and so many surveys out there, right? They say that most, not just big enterprises, even medium scale to big enterprises have two or more active clouds in their company, right? So they have like Azure, AWS, or AWS and GCP, or whatever, two or more clouds actively in production, even so small scale companies and above, right? But the problem is, I think the number was 76% of the companies have this, but the problem is just 29% of them have adopted platform engineering strictly to manage this, properly. And that's a big market gap that we see. And that's where Cordant can help. So while this is the reason and the technology, the technological problem around it, the solution space also was quite interesting for us because when we began thinking about a solution for this, of course, there are many solutions that exist. It's like this is not the first solution that's coming out for multi-cluster, multi-cloud, but the approach that we've decided to go, like we've already talked about a lot in this call, is the open source way, right? So there are a lot of infrastructure as code tooling, IAC, right? There's this cross-plane, Terraform, Ansible, and if I have to go back, before all these came, it was literally like Python scripts and shell scripts that was doing the job. Yeah, it was doing the job, but like at what cost, right? So we sort of wanted to go away from the direction of IAC tools, not be tied to any particular tool, but go the native Kubernetes way, where we adopt the approaches and the mechanisms that are followed in the upstream Kubernetes 6, which is Cluster API, right? So Cluster API is this project that is directly under the Kubernetes org, which talks about a repeatable, scalable way to provision clusters, right? It's as simple as that. And every cloud provider out there has provided or developed their own controller onto this CAPI, right? So Cluster API is shortened as CAPI, and every cloud provider has their own implementation of CAPI. So Kappa for AWS and CapZ for Azure and CAPI for VMware, all of them have come together and agreed that this is sort of like the standardization that we will adopt and move forward from here, right? Now, this being the base, what we noticed is even with Cluster API, there are challenges and complexities involved, especially when you want to do multi-cluster management. So for example, Azure, the portal is amazing, right? Like if you want a Kubernetes cluster in Azure, it's just a few clicks away. You go log into the portal, sign up, and then click, done. You have a Kubernetes cluster running in a few minutes or so. But what if you want to do the same thing on AWS? What if you want to do the same thing on OpenStack, your own cloud, private cloud, and all these things, right? That's where Cordant unifies these things. So we've created this custom resource called as cluster deployment, right? I'm gonna show you what that looks like, but I have one that's already deployed here on Azure Cloud, right? So we have something called a cluster deployment, which contains the entire configuration in one single YAML file that defines how your cluster looks like on your particular cloud, right? So taking a step back, while that's the result, these are the building blocks. So again, everything is just YAML driven, everything is Helm charts driven, right? So it's all upstream Kubernetes. For every cloud provider out there, we have an equivalent cluster template, right? So again, for every cloud provider, we have two deployment mechanisms, standalone and hosted control plane, but like that's not super important. So I just want to mention that and leave it there. So for this demo, I'm using the Azure standalone template, right? This becomes the day zero of deploying cluster from scratch and then managing it. Now, what about day two, right? This is the second part of the problem. So fine, I've got my cluster. You've made my job easier by having it all centralized. But what about my actual applications and all the services that are required for any developer to actually run any meaningful workload, right? So for that, we have service templates. So service templates perfectly is sort of the mirror image. They encapsulate the other side of the story in Cordant. So these two being part one and part two. While cluster templates define the infrastructure configuration, service templates defines the application configuration. As simple as that. So service templates, again, are nothing but a wrapper around a help chart. And to do this more openly and to sort of provide a marketplace of sorts, right? We are developing this out in the open by creating something like Docker Hub. So how Docker Hub is for container images, Catalog is for service templates. So as long as any application has a Helm chart, which like most of them do, even if you don't, your own application, you can easily create a Helm chart around it. You can create an equivalent service template for it, right? So later in the call, I'm just going to open the Catalog website and show you like all the active services. But yeah, let's leave it at that, right? So for the current demo on this particular cluster, you see all these things existing. So for example, Cert Manager is a common service that you'll end up using no matter what application you do, right? Istio and then yeah, Istio forms like base, Istio-D, and then the gateway, right? And then for this particular example, I'm taking an AI-driven one, so you will see a lot of things that are related to that. GPU operator, and then Knative, and then Kserve, right? So let me briefly talk about each service template. So why the GPU operator? If you have ever tried to deploy a cluster and then install all the required dependencies and components and drivers, you know it's a pain. Like it could be Kubernetes or it could be bare metal, it doesn't matter. But getting everything ready and setting it up so that your development team can start deploying their AI apps is a bit of a pain right now, right? It's been difficult. I think lately NVIDIA has worked a lot towards improving this, onboarding, but then it's still a turmoil. With cluster deployment and service template, what happens is we already have this ready for you. All you got to do is specify the service template and that's it, right? So I'm going to show you. I think these are the two parts. Now let us finally see how the cluster deployment looks like. All right. So I've just named it demo B. We mentioned the template that we want to use, the credentials in order to communicate with the cloud, and the infrastructure configuration. So this should be very familiar to anybody who's worked with cloud, wherein you specify what you want, right? Like basically how many control planes you want, how many worker nodes do you want, what control plane image, and so on and so forth. And right here for the worker node, I'm using the NVIDIA Tesla T4 GPUs. So that's it. As long as your subscription on Azure Cloud has access to whatever GPUs you have, just mention that favor and this cluster will pick that up and proceed further. So that's the infra part. Now onto the service part, it's just about mentioning these. So I have the service spec.services, and I just mentioned all the list of services in an array with the option to override the values.yaml. Right? So I've mentioned the GPU service operator, the Istio stuff, the Cert Manager, Knative, and Kserve. All right. Now let us go ahead and apply this, or maybe not, because I've already applied, right? So I don't want to cause any conflicts. In the interest of time, I've applied this link just before the recording started and named it demo A, and we have it. So to give you a context, if you have to do this manually, it literally takes like anywhere like from a few hours to a few days, depending on the policy set up in your company, to go through all the approval processes and the credentials and so on and so forth. But once you've set up all the credentials and they're all in place, in my experience, I've observed Azure to be the fastest in cluster deployment. I'm not saying that because it's a Microsoft podcast, but genuinely. So I've seen on an average a cluster being spun up in like 10 to 15 minutes max, right? That's really good. If you compare it to the traditional ways we used to take like hours and a lot more effort to just about applying it using kubectl apply -f with your YAML file and then wait like 10, 15 minutes and your cluster is up, right? So now let's go to the cluster. Let's go to the cluster here and let me do the config view. There you go. We have the demo A. It's running in South India region in Azure Cloud. So here's the proof that the cluster exists, right? I've mentioned like one control plane and 2 worker nodes, and we have that. And then the service spec, whatever services we mentioned, are also deployed. So let's start with the NVIDIA GPU operator, the service that we mentioned, and check out the pods, right? So just a brief on what happened underneath is that as soon as you applied the cluster deployment, the Cordant controller that's running on this management cluster picks it up, reads your configuration, interacts with the cloud controller managers that I talked about, depending on what template you're using, and then talks to the Azure cloud, spawns the network interfaces, load balancers, IP addresses, the subnets and VNets and whatnot, all the necessary components, and finally the VM, the instance, installs the kubectl components and controller manager and everything, makes that into a proper Kubernetes cluster. And once that is ready, then moves on to the second phase, which is taken care by SvelteOS, right? I didn't mention SvelteOS, but that's the service application delivery that's happening. So the service templates are being handled and deployed using yet another open source project called as SvelteOS, right? Now the second phase has worked and it has created the namespace, installed all the things that it's supposed to do. So obviously this is completely up to the application to do what it's supposed to do. So NVIDIA operator has done its part. And as a result, what we have is our node having this beautiful annotation, nvidia.com GPU is equal to 1, which is the proof that Kubernetes cluster has recognized the underlying infrastructure to have a GPU instance, and then it's ready to accept workloads on that particular node, right? And similarly, the other namespaces, just to close the loop on this, I mentioned kserve and knative, right? So these pods are up and running as well, along with the cert manager and Istio2. So yeah, to sum it up, this is the entire flow. And just to show you like an example of how things are working, this is picked up from NVIDIA's documentation, where it's a very simple CUDA vector add example, which does some vector addition that is based on GPUs, right? So I apply that, and because I'd already done this, the image was already downloaded, so that was quick. And there you go. It successfully utilized and added 50,000 elements in vector add utilizing the underlying GPU resources, right? So this is the overall thing. Let me pull up this monitor as well. And this is our Azure cloud, right? And we have the demo A control plane, demo A worker node 1 and worker node 2. So this is what I meant, that because I've provided the credentials for my subscription and for my tenant, the compute and all the other resources are right here. Lastly, this is the catalog that I mentioned. So Cordant.io is the is the project. Let me open the GitHub for it, right?
There you go.
How about now?
Yeah.
Sorry. Yeah. So as I was saying, the Cordant catalog, this is the catalog that I mentioned, where I think at launch we started with about like 20 applications or something, and then now it's expanding. Like I think it's 50 plus right now, where we're constantly adding more and more. And hey, like if you don't find your application here, it's like you're welcome to contribute, right? And this is the other part that I mentioned. Cordant, the organization, and KCM, which is where most of our Cordant development happens. We even pretty much do the project planning and community calls and everything out here. So you're most welcome to join the community calls, take a look at what's happening, and then just listen in, right?
Cool. Do you guys have anything else that you want to talk about or comment on?
I think we want to sort of maybe talk about where the future of platform engineering was going. That was one of the topics we had discussed. And, we in the open source program office, Mirantis have really been trying to figure that out ourselves. It's really fascinating playing with a lot of the AI coding assistants, and that they're very sophisticated. You can do a lot with them, but I still see this big gap between what developers are getting and what operators are getting. So we've been spending a bunch of time trying to look at things like AI ops, Kubernetes assistants like Kate's GPT, and trying to understand kind of what the future looks like. Because if we want to get the full leverage out of these AI tools, we need them not just for coding, but also helping us in production, right? The way I always think about it is you want the computers to do all the grindy, hard to do stuff that the technologists don't need or want to do. So an example of that in operations land might be assisted root cause analysis. Like there's an event in production, go out and find out all of the things and do correlation across networking and storage and the app stack and the logs and come back to me and give me some kind of initial analysis, so I'm not spending hours digging through all of that data trying to find out what's going on. And so we haven't really seen that get to where it needs to get to yet, but you want to have this smooth path from like, I'm working on the code to my laptop, I put it in CI/CD, I push it into the platform that platform engineering created. Platform engineering deployed, the platform deploys it and is running in production. And each of those stages, I want that AI assist from the coding all the way to troubleshooting in production. And we haven't seen that yet. We've been doing some early experiments, but I think that there will be more value in platform engineering if we start asking ourselves what kind of AI assistant tools can be there that help operators, not just developers, and also that help bridge the gap. An example of that might be, another one might be, an event occurred in production. The operator is going to look at it maybe more from the infrastructure side. How does a developer get the information from the telemetry system and get some assist with doing the root cause analysis across the entire telemetry system? Because we've all seen kind of, Grafana dashboard hell, right? Can we have an AI assistant build me a custom dashboard cross-cutting across multiple pieces that has all that kind of proof of work that shows kind of like what happened, around that event in production, so that a developer and operator can look at it together and kind of come to some conclusion about what might be going on in production and how they can solve it.
Have you seen the SRE agent from GitHub? Have you seen those demos?
Yeah, we've been looking at all that different stuff, and I think I think we're just at the tip of the iceberg in terms of what's possible, and we're still learning, like, what it looks like. I mean, the thing about coding and coding assistants is like they're code is well documented by and large. There's tons of documentation about it, but like running your own app that you custom built in production, there's less documentation. It's not, so it's a different kind of environment. That's also why you see the AI tools not being as good with like infrastructure as code, right? Because the number of examples of Terraform configurations that are out there versus Python code is very different, right? So it's a question about how much data there is to train the AI tools. So I think we're still at the beginning of making these really, really useful to us. And I'm just postulating that the better they get and the more they're wired into sort of the platforms we're building for platform engineering, the more value we'll get out of them.
Yeah, I just to be honest, like I never really think about the code as the biggest problem. I always think about the infrastructure as being the most painful part because I hate infrastructure. And when I saw those SRE agents just going off and saying they noticed the service was down because, the things had reached capacity, and so they stood up extra stuff and things like that. And I just thought back to all of those years I spent in IBM with a pager, getting woken up in the middle of the night trying to get on the phone to people in Brazil or India, and like not even knowing where in the world is the server to then get an engineer to try and go to it. And the idea that this little agent could be looking into what's down and standing something up in the meantime while I was still getting out of bed and getting my coffee was just delightful to me. So yeah, I know everything has a long way to go, but like that kind of automation, I am such a huge fan of.
I think we've all been there. I mean, I remember one particular instance where literally the whole world was on the call. Product managers, project managers, and so many people, right? And ultimately, like, we're trying to figure out what's wrong, and we sent out a field engineer to the data center, and guess what? The AC was off. just the one vent or whatever, one rack. That particular bit, the AC was off, and it's a huge unmanned data center, so there's nobody like to monitor it constantly. But then remote engineers like me sitting and trying to dig through logs and stuff. Yeah, it's a pain. I think a lot of this will be a little bit made smarter with AI with context. I think the key part is with context they can be smarter, because without they can be like guessing from A to Z, all of it, right? And yeah, just one thing I wanted to comment is, like, we've been seeing just a whole lot of tools that do like crazy things. If you just look at the end result that they're able to accomplish, it's amazing, right? It's like, whoa. But the challenge with that is, how do you actually make it useful in a production enterprise setup, right? Yeah, like I've got these tools, I've got models that are getting smarter every day because someone out there is doing all the hard work to train the individual models like Claude Sonnet 4 or GPT-4 or whatever, right? Gemini 2.5. But practically, how do I integrate that into the flow that we have today? Because it's not magic that tomorrow we'll wake up and everything is changed and it's being replaced by AI. That's not going to happen. So what's going to happen is a proper integration into our existing life and into the existing flow. And that's where we're trying to spend a lot of effort into not just looking at the tools, but looking at how best these tools can help. So one of the examples Randy gave was the Creators GPT. Like, that's amazing. I think they're one of the quickest to get into CNCF. They got like 50,000 plus stars in just a few days because it was amazing. It was able to just go see, okay, what pods are down? Why is the pod down? Is it a problem with the resources or something else? And all that, right? But you still got to integrate that AI assistant into your workflow, keeping security in mind, because you don't want data to go out, or you don't want the LLM to do something that you're not comfortable with, right? It poses a whole bunch of security threats as well. So that's another area where we're focusing on how to solve this in a holistic, proper way, right? If that makes sense.
Not only that, but you got to think about budgets. We experimented with Kate's GPT to basically make it sort of a live assistant. So it was sitting there and it was monitoring your cluster, your Cordant cluster in real time and looking for deployments, and then helping as an assistant to detect if there are any problems with cluster deployments. And we found out the hard way that Kubernetes provides a lot of context. So we were shoving huge, massive amounts of tokens into OpenAI, and we blew the budget out basically every day until we realized hey, like this isn't the right way to use this particular tool. If you did have a tool that was going to be a 24/7, assistant rather than one that's kind of on demand and run by an operator, you'd have to have a way to sort of gate it so you're not shoving millions and millions and millions of tokens down to these frontier models on a regular basis. It's just too expensive. So the whole way that we use these tools and learn how to use them kind of from operational perspective, it's nascent, it's new. We don't know how to do it yet. We don't know how to do it from a secure point of view. We don't know how to make sure that it makes sense from a financial point of view. It's really the early days, but that's also when it's the most exciting, just like the early cloud days.
Yeah, I was thinking that just this morning, that we're kind of we big tech companies have given the world the wrong impression about the cost of things. Like if I want an image drawn, I will just go to Copilot and have it create this thing for me, which in the past you would have to go to a designer or ask someone to create that for you, and you would pay them a fee. And now, you can have stuff created and generated so easily, and it's free, but it's not free. It's not free. Big tech is absorbing the cost for those things right now because they're wanting to get people hooked in and see all the use cases. But yes, in fact, it is expensive if you use things lazily. If you do just let all the data go into it, if you don't think about what should the architecture be, what should be the design, what should be the real use case. So if we don't add our human expertise into that loop, then it's very wasteful, and people will waste a lot of time and money before realizing what is the best way to move forward with that. You can do amazing things, but yes, you need to really invest in your human capital as well alongside it.
100%.
Yeah, it is exciting. I am super excited, but also, yeah, there's so much that people are thinking about the wrong things. I think that's probably my concern, that they don't, the things that they don't need to worry about have already been or are in the works for being addressed. So for example, risk, security, governance, bias, all of those things, there's a lot of work that's been done into operationalizing that stuff. But things about how you should use it and what you should be doing with it, and the most effective way to do it, and how you put those checks and balances in that loop, because humans are we are so lazy. And if you let AI do stuff and 90% of the time it's doing it fine, then they will just go off and have a coffee and a lie down and forget about it. And then it will start doing something wrong. It will go down a rabbit hole, and it will, suddenly burn through, your entire budget. Absolutely. Because it's gone on the wrong track and no one was watching it. And that's the thing. How do we keep humans on track?
The way that we've been talking about it internally is like the AI tools are like these toddlers, like idiot savant toddlers, like they know how to write amazing code and put things together from a technology perspective, but they're 4 to 6 year old children, and if you leave them unsupervised, you will get a surprise. But if you're there and you're very explicit with them and you talk to them in the right way and you act as the mentor and guide, then you get this incredible capacity to solve problems, Rain Man style, right? That's if you come at it with that attitude, then I think you get better results. Whereas if you're just want to put it on autopilot, which I have tried a few times and did get bitten, you realize that that's just not going to work.
Sometimes it works, sometimes it's perfect, and then you think, oh yeah, this is great, it's always going to work, and then it doesn't. And yeah, I have done it so that I got it to do a thing for me, and it took it a few minutes, and the next day I tried to replicate that, and I spent the whole day arguing with it. And that, I think, is a valuable experience for me to learn that, yeah, it is possibly going to be different every single time. That is the nature of generative AI. You cannot lock it down, even if even if you give it a zero temperature, even if you tell it may not make things up, even if you put all of these things in, it's still gonna at some point do something to surprise you. So you've got to be paying attention. You've got to be in it with it. Co-pilot, not a replacement, but a friend.
Yeah, I think we've had a lot of debate on this. So there's one guy in the team who's a bit skeptical than others. So deterministic versus non-deterministic outcomes, right? This is the world we're in, and like we gotta play. There's no other choice. And to be more efficient, I think we have to sort of combine the both. The programming that we know, the code that we write for so many years, we know it's a deterministic outcome, but with whatever limitations it has. And then combine that with AI, which is a non-deterministic outcome to some extent, right? So combining these two, and it's like almost an art, right? To balance it out so that you get the best of both worlds. Yeah.
I really like that as a summary. That's a really nice way to put it.
I mean, if we'll never run out of topics with AI, but Michelle, if we do, then let's go into philosophy, and I'm sure we can talk all day.
You and I both know that we can. Cool. Okay, so future of platform engineering is more and better, smoother open source automation, ideally hands in hands with human expert engineers, is what we're saying. Is that the summary?
I think that's a great summary. Yeah. Human in the loop. That's not going away.
Cool. Okay. Well, thank you, Andy. Thank you, Barath. This has been amazing insights. And I think that people are going to come back to this episode time after time and look at it. We have been answering questions online during this episode, and if you stay online, we will be there for another 10 minutes or so to answer any remaining questions. We're going to put all of the things that we've talked about, all of the resources in the GitHub repo, so you'll be able to investigate what they have shown here today. And yeah, thank you all for joining us, and I look forward to seeing you all again next month. Thanks, guys.
Thank you so much. Thank you for having us.
Cheers.
Bye.